Hello, welcome to MFM2PI. This is our 5th unit, Trigonometry, and this is our 5th lesson, Finding Side Length. The objective of today's lesson is to find the side lengths of right-angled triangles using the 3 primary trig ratios. Which trig ratio to use? That's a big part of what we're going to be learning today. So let's start by considering the situation in which we would be called upon to find need to find a side length. So if we are given one side in a right angle triangle, and we are given one angle, and we need to find, I guess we'll call it another side. This would be a scenario where we would want to use the primary trig ratios. If we were given 2 sides in a right angle triangle, we could just use the Pythagorean theorem, which was lesson number 1, to find the other side. But in this case, we're only given one side and one angle. We're going to find another side using primary trig ratios. Now, as usual, we have a list of instructions here, a set of instructions on how to find side lengths. I'm not going to read through them. You can read through them at your own pace or in your leisure. I'm just going to take you through an example of how we would go about actually finding our side length given one side and one angle. So let's start here with our first triangle. Our goal is to try to find the length of side little k. So where is side little k on our triangle? Well, there's angle k, so that would make side little k over here. That's what we're after. So the first thing we're going to do in trying to find side little k is we are going to choose a reference angle. And I'm going to color in our reference angle. I'm going to pick the one that has the angle already provided for us at 23 degrees. The next thing I'm going to do is label all 3 sides of my triangle with respect to my reference angle. So this is my hypotenuse over here, this is my opposite, and this will be my adjacent side. So I've got all 3 sides labeled. The next thing I'm going to do is I'm going to determine which trig ratio I want to use. And I'm going to write out SOHCAHTOA for this one, just so I can sort of have it here. And what I'm going to do is see what piece of information in this triangle I already have. And I already have 48 centimeters right here. And that happens to be my hypotenuse. So I'm going to put just a little check mark under hypotenuse right there, which means no check marks at TOA. We're not going to use the tangent ratio this time. Next thing I'm going to look for is what side do I want? And in this case, I want the adjacent side, which is right here. So I'm going to put a little check mark under the A, which means that I'm not going to use the sine ratio this time either. I'm going to use the cosine ratio. So I'm going to write out sort of a bare bones version of the cosine ratio. So that's going to be the cos of 23 degrees is equal to the adjacent side over the hypotenuse side. Now I'm going to start to fill in some of the information that I know. Actually, you know what? I'm going to erase that 23 degrees. Let's call it what it is, which is cos of angle P at the moment. Now let's start to fill in information that we've got. So the cos of 23 degrees is equal to the adjacent side, which I don't know, over my hypotenuse, which I do know is 48. Now I want to solve for angle K. The method I'm going to suggest that we use to do that is consider that the cos of 23 degrees is actually a number. If you were to type this into your calculator, as I'm going to do now, if I type in cos of 23 degrees, I'm going to get 0.9205048553, etc. And it goes on and on. So this is actually a number. It has the word cos in it, but it represents a number. And like any number, I can write that number over 1. And by doing so, I've created a proportion, 2 ratios set equal to each other. A method for us to solve a missing value in a proportion is to cross multiply, as you would have learned in grade 9 and we reviewed here in grade 10. So let's go about cross multiplying. It means our first numerator, which is cos of 23 degrees, gets multiplied by our second denominator, which is 48, and that will be equal to our second denominator, which is 1, multiplied by, our first denominator, which is 1, multiplied by our second numerator, which is k. So now I'm going to actually type this into my calculator. So I'm going to type in cos of 23 degrees times 48, and that is going to give me 44.18, and I will just round that to 44.2, and 1 times k is going to be equal to k, so that works for me. So this is a method I'm going to suggest for solving for a side in a right angle triangle given a side and an angle. What I'd like you to do is try to model this as you solve the second of these 2 examples. So hit pause here in the video, try this one on your own, try to follow the steps that I gave you or that I just showed you, knowing that this side here is side little k. Go solve it. When you've got an answer, come back and we'll see how you did. Okay, you're back. Let's start by labeling our reference angle, which again I'll choose 17 degrees here. So there's my 17 degrees. From there, this side here is my hypotenuse, this is my opposite, and this is my adjacent. Now I'm going to set up that SOHCAHTOA again, and I'm going to try to determine which of these trig ratios to use. So what piece of information have I been given? Well, I've been given my adjacent over there as 3.9. So I'm going to put a little check mark by adjacent. So no sine ratio this time. Now I'm going to look at what I want. And what I want is opposite. So I'll put a little check mark beside the O. So no cosine ratio this time. We are going to use tangent. So I am going to write out the tangent of angle K is equal to the opposite side over the adjacent. And I'm going to start to fill in some of that information I know. So the tangent of 17 degrees is equal to the opposite side, which I don't know, over the adjacent side, which is 3.9. And again, the method I'm going to suggest to solve here is that we create ourselves a proportion. So I'm going to write out tan 17 degrees, which again is a number. Despite having the word tan in it, I'm going to write it as a number over 1, and I'm going to cross multiply to solve. So this time I'm going to try to keep the k on the left side, because I like it there. So there's k times 1 is going to be k. And on the other side, we're going to have the tan of 17 degrees times 3.9. And we can type that into our calculator. So I'm going to type in the tan of 17 degrees multiplied by 3.9 is going to give me 1.19, etc. So I'm going to do 1.2, and our unit of measure is kilometers. So this is how you go about finding a side in a right angle triangle given an angle in one other side. But what you'll notice about these first two examples is that the variable that we were after was in the numerator of our trigonometric ratio. It was always in the top part of the trig ratios. What if it shows up in the denominator? It's not a big deal. There is one more additional algebraic step to isolate that variable. So let's have a look at one of those guys now. So heading to the bottom two examples, we are now trying to find the length of side little I. So little I is a little I right here. So if we want to find the length of side little I, let's start by labeling our reference angle, which again I will choose here as 58 degrees because it's kind of easy, and I'm going to label all the remaining sides. So there's my hypotenuse, there is my opposite, and there is my adjacent. Now from here, I'm going to set up my SOHCAHTOA again. I'm just cutting and pasting it. You guys got to write it. This is just me being lazy. So let's paste it in, and let's start by figuring out what it is that we have. So we have been given our opposite side. That's 11.7. So let's put a little check mark under the O. So no cosine for us. And now what is it that we want? We want the hypotenuse this time. So there's another check mark. Not tangent this time. We are going to use the sine ratio. So I'm going to write this out. Again, just a bare bones one here. So the sine of angle P equals the opposite side over the hypotenuse, and now we start to fill in. So the sine of 58 degrees is equal to the opposite side, which is 11.7, over the hypotenuse, which is little I. I don't know what that is. Same method to solve. So far, we're going to turn this into a proportion by putting sine 58 degrees, which again is a number, over 1, and we're going to cross multiply to solve. So let's set up that cross multiply right now. So we are going to have sine of 58 degrees multiplied by little I equals 11.7 times 1, so we'll just leave that, 11.7. So before, we would have already isolated our variable. This time, we have our variable I being multiplied by sine of 58 degrees. So how do we undo multiplying something by sine 58 degrees? We are going to divide by sine of 58 degrees. And we're going to do this on both sides of our equation. So there's our sine 58 degrees. So on the left side of our equation, all we have left is our little I, which is good. And on the right side of our equation, now I'm going to type this into my calculator. 11.7 divided by the sine of 58 degrees, and that's going to give me 13.796, so that's going to be 13.8, and our unit of measure is meters. So we have little I equal to 13.8 meters. You'll see there was that one additional step where we were called upon to divide both sides of our equation by whatever our variable was being multiplied by after our cross multiplication. So that's our extra step. What I'd like you to do is hit pause in the video and you go and try to find side little I, which is right here on this last example. When you're done, come on back and we'll see how you did. Okay, you're back. Let's start with labeling our reference angle. So here's the reference angle. There it is. This side over here is the hypotenuse. Over here we have the opposite, and over here we have the adjacent. We're going to write out our SOHCAHTOA so that we can figure out what's what. There's SOHCAHTOA. So what side do we have already information for? We have opposite. So I'm going to put a little check mark under the O's. Sorry, cosine, not you today. And what side do I want? I want my adjacent side. So that's going to be tangent that we use. So I'm going to write out a bare bones version of tangent. So the tangent of angle B is equal to the opposite side over the adjacent. And now we start to fill in. The tangent of 31 degrees is equal to the opposite side, which is 22, over our adjacent, which we don't know. As before, we're going to set tan 31, which again is a number, over 1, so that we can more easily cross-multiply to solve the missing value in this proportion. So here we have the tan of 31 degrees times little I is equal to 22 times 1, so we'll just leave that as a 22. How do we get our variable alone? Currently it's being multiplied by tan of 31 degrees. We undo that by dividing both sides by tan 31 degrees. This is now what I'm going to type into my calculator. I have little I is equal to, and I type in 22 divided by the tangent of 31 degrees, and that equals 36.61, so 36.6, and this is millimeters this time. And this is how you go about finding the side length of a right angle triangle given another side and a reference angle, or I guess an angle. We've looked at it from the perspective of finding the variable when it was in the numerator and finding the variable in the last two examples when it was in the denominator. From here, head to your self-assessment, then your mastery test, and then on to lesson 6, which is actually a graphic organizer of everything we've done so far. So good luck.